Oh, you want the death stare? Where are my glasses?
No.
No. I got this great death stare. I named it after Mrs. Carlton, my 5th grade teacher, because she used to do this. She was friends with my mom. It was the worst because she told on me all the time. She would do this. Like, for some reason, over the glasses is way more terrifying. Okay. Guys, I'm going to try to take what happened yesterday and make it less painful. Because it was, in fact, painful. Yeah, we're all in agreement? Okay. So the basic idea is when we make these rectangles, the height of the rectangle is the value of the function somewhere at this point called C. Okay? So the height, so if we're doing length times width, the height is going to be f of this CI. And the reason we use that CI is so we can use this summation notation. That sometimes we're talking about the first rectangle, and then the second rectangle, and then the third rectangle, okay? That's the only reason why we use CI instead of just C, okay? Times, what's the width of all of the rectangles? Delta X. So, and then if I want to find the area in between those two things, okay? In between two values, essentially what I'm trying to find is the sum of all these itty-bitty, infinitesimally small width rectangles. In other words, I want delta x to approach 0. Another way of saying delta x approaches 0 is if I make the rectangle smaller and smaller and smaller, how many rectangles will I have? As delta x gets really tiny. An infinite amount. So we could either think of it as the limit as my number of rectangles approaches infinity, or we could think of it as delta x approaches 0. Both of those two things are equivalent statements. Okay. So we can find delta x by doing b minus a over n. We kind of talked about that one yesterday. Okay. And that value for c, that CI value, is always going to equal, well, essentially what we're going to do is we're going to take wherever we start and add delta x over and over and over again, yeah? And how many times to get to each rectangle? I times. So delta, or CI, will always be A, whatever that initial value of my interval is, plus I times delta x. And I'll let you guys look at that for a second. And then all we're going to do is take the limit as n approaches infinity, or take the limit as delta x approaches 0, same thing. All right. So let's say I ask you guys, what is the area bounded by the function f of x equals x cubed and the x-axis between 0 and 1? Is everybody with me so far? Do we know what delta x is? How could we figure it out? B minus a over n, and in this case, that would be 1 minus 0 over n, which is 1 over n. Okay, what about CI? CI is A, which in this case is 0, because that's my initial value for x, right? Plus I times delta x, we still doing okay? Okay, so what we want to do is find the limit as n approaches infinity of f of CI times delta x. That's what we're doing that's what we're going to do every time here. Okay? Well, that would be, in this scenario, that'd be the limit as n approaches infinity. Are you cool if I call ci 0 plus, if I simplify ci to just be I over n? Is that comfortable? Okay. Well, what would f of I over n be? What was my function? So f of I over n would be I over n cubed. Times delta x would be times 1 over n. Are we feeling okay so far? Could I simplify that?
Can we not say I is 1?
We cannot say I is 1. Over n to the 4th. Yeah, I'll let you guys look at that. The reason we can't say I is 1 is I is standing for whichever rectangle we're at. Yeah, it's not I as in like the imaginary number I. You know what? I'll flip over to start using K's instead. It's the same idea.
That would be helpful.
Yeah. Are we okay? And then that n to the 4th is a constant. Yeah, so this is really 1 over n to the 4th times the limit as n approaches infinity. Oh, I forgot my sigma. These should all have sigmas here because we're adding up all those rectangles. Now, what is the summation of I cubed? It's a fancy formula for it, right? A formula that I've told you I'm going to give you on the test, so you don't need to stress about it, okay? All right, so that sum of I cubed, for I equals 1, 2, 10, okay, would be n squared, n plus 1 squared over 6, 8, 4. I have that 1 over n to the 4th from before. And then we're going to take the limit as n approaches infinity. All right. I apologize. I'm learning what takes what in sort of space. If I multiply this top out all the way, okay, this is where I will end up. N to the 4th plus 2n cubed plus n squared over 4n to the 4th. And then we'll be taking the limit as n approaches infinity. What is that limit as n approaches infinity? One over 4. And so the integral from 0 to 1 of x cubed dx is also equal to 1/4. Those two things go hand in hand. We will do another example, I promise.
How does that like simplify to 1/4? Like, I'm not,
When you,
like, why is that?
so, so essentially,
They both have
so, I mean, so essentially, this is a definite integral. We're gonna talk about these in more detail tomorrow, right? If I integrate the curve x to the third over the interval 0 to 1, that's an equivalent statement to finding the area between 0 and 1 on the graph.
No, like how does the limit simplify to 1/4?
Okay. So essentially, the limit, this is where we did, if we multiply through by 1 over the largest exponent.
So you need to
So if we did that, we'd then have the limit as n approaches infinity of 1 plus 2 over n plus 1 over n squared over 4.
So I just take too long to do L'Hopital.
Yeah. I mean, we could do L'Hopital. We can eventually get to the place that as n approaches infinity, the largest exponents are the ones that are what I would call the dominant ones. Okay, so as you're approaching really, really big numbers, you can almost look at it as this 1 and this 4, and everything else is going to be so small relative to those ones and those 4s that it's really the 1 and the 4 that make it happen. That's what's really going on. We good? All right. All right, so to use this definition, we are going to take the limit as n approaches infinity, the sum, and we'll use k equals 1 to n, okay? And then we're going to do f of ci times delta x. That is going to be very, very consistent. That part's always going to be there. Now, in this case, what is ci? A plus k times delta x. Sure, but what's a? In this case, a would be 1, because that's the lower boundary of the area I'm trying to find, that of x. And then, can we figure out what delta x is? It would be 2 minus 1 over n. My upper boundary minus my lower boundary divided by n. So now this isn't 1 plus k times delta x, it's 1 plus 1 over n. It's 1 plus k times n.
Why was A for the one we just did? Why was that 0?
Because it's always these two numbers. So this is 0, this is 1. Whereas on this case, we're doing it in between. Like if I drew a picture of this, 4 minus x squared is a parabola kind of doing this. Yeah?
Mm-hmm.
And between 1 and 2, so we're finding this area. So my starting boundary is 1.
But like, why is the I equal 1 for the previous one?
The I didn't, the delta x did. The I was here.
Where?
This, like, it was I all the way up to here. It was still I.
Okay. just because when we did the a plus k times delta x for the first one, our a was 0, but the I is equal to 1.
Yeah, so this is the CI, or this is A, this is delta X.
Okay. Yeah, okay.
So to find this limit, I'm going to do the limit is n approaches infinity, k equals 1 to n. F of x in this case is 4 minus x squared. This time it's going to be 4 minus 1 plus k over n, the quantity squared. And then times delta x will be times 1 over n.
Did K over 10.
Thank you. How are we feeling so far? All right, now, everything from here is really just doing some algebra. So the first thing I'm going to do is multiply it out, just that 1 plus k over n squared. And when I do that, I get 4 minus, and then I'd have 1 plus 2k over n plus k squared over n squared. All times 1 over n. Simplify that some more. I'm going to do a couple of things. I'm going to call that 3 minus 2k over n minus k squared over n squared times 1 over n.
Where'd you get the 3?
4 minus 1. So this is 4 minus 1. It became the 3, and then I just distributed that negative sign through the rest. All right, and then the other thing I'm gonna make this, the limit as n approaches infinity of 1 over n times those sums. So I did, to get from here to here, I took this 1 over n, since it's just a constant, and I moved it in front of all of those summations. And then I just gave the summation sign to the 3. I brought the 2 over n out and just left the k. And then the k squared. by side for a second. And the intent of doing that, okay, is that we don't want any ends with our summations. We want them in front of the summations away. Okay, that was my intention. Like, my goal here was just trying to make it so that you either have a constant or a k. That's it. And the reason I only want it to be a constant or a k is my summation formulas all are about constants and k's. Do we get kind of the why behind that now? Then we're just going to use each one of these formulas. So what should the sum of a constant is just that constant times whatever number's up here, which in this case is n. So just this piece becomes 3n. Are we cool? Minus. We'll have 2 over n. What does that sum of k equal? No. Because k is not a constant. It would be n times n plus 1 over 2. Minus 1 over n squared. That k squared becomes n plus 1, 2n plus 1 all over 6. No more summations. They're gone. Because there's nothing to see. Do you guys trust me to multiply that out nicely? Yeah. Or do you guys want to do it real quick?
No, I think.
You guys trust me on that? So I'm going to put that n squared at the bottom for now. And that multiplies out to 2n cubed plus 3n squared plus n. Man, this is exhausting. You guys mind if I distribute that 1 over n now? All right, I'll get the limit as n approaches infinity of 3 minus 1 minus 1 over n minus,
Hey, wait a minute. 6n squared.
hmm?
The denominator should be 6n squared, not.
Thank you. Thank you. Minus the whole fraction 2n cubed plus 3n squared plus n over 6n to the third. Yeah? How am I doing? Are we at a place where we can take the limit yet? It feels like we're at a place where we could take the limit.
Do you have a plan this afternoon?
Uh-uh.
Can I talk to you at 3 real quick?
Is it about something that your mother already talked to me about?
Probably.
Okay, Grandview for the Smith family is a family affair, right?
Yes.
Anyone know the answer yet? Because frankly, I'm not sure I do anymore.
I got 5/3.
Let's see. This becomes 2. This goes away. This becomes 1/3. So 2 minus 1/3 is 5/3.
Let's go.
So wasn't that easy?
Yeah.
Yeah. Didn't break a sweat. I don't even have a headache yet.
Well, the last thing we're gonna do today isn't bad at all. You're gonna be very excited for the last thing that we're gonna do today.
Get DQ.
No, I already had ice cream. Otherwise, you probably would have been able to convince me.
Darn.
Which I'm sure you guys are all grateful not to have to use. Okay? We can calculate.
Last thing we do.
Okay.
Yeah, last thing we do is have a chill day.
It's not gonna be a chill day. It's never gonna be a chill day.
I don't think it could be a
Well,
chill day.
don't say never. You know, never say never.
All right, you guys, I drew you a little picture. And in this picture, you can see we have the line y equals negative 2x plus 6. The y-axis, the x-axis, and the line x equals 5. Everybody with me? And I want you to go back to like the 3rd grade version of you. Like if we asked those kids what they saw in this picture, what do you think they would say?
Triangle.
It's an N.
They'd see an N? Okay. What else might they see? Lines.
Colors.
Right angles, colors,
Triangles.
triangles, maybe some triangles.
Oh, big rectangles.
Okay. I want to focus on the triangles. And then there's lots of things we can measure on triangles, yeah? Our triangles have right angles, which is actually going to end up being quite useful. They have perimeters. They have different angle measurements. What else do they have? Something that, I don't know, we've been kind of working through in a much more complex manner. They have an area. Is everybody with me? Okay, so if I ask you guys, what is the area in between the line y equals negative 2x plus 6 on the and the x-axis on the interval 0 to 3? Well, let's see. Are you with me that I can see that the base of that triangle is 3 and the height of that triangle is 6? So if I asked you to find the area of that triangle, couldn't we just use like the fact that it's a triangle to find the area? Okay. What is its area? 9. Is everybody good with that? Okay. What if I said instead of between 0 and 3, what is the area between 3 and 5? Well, now I might look at this and see this area, or this length is 2, and this length is well, we're going to call it 4 for now. And if I asked you the area of that triangle, you would say 4? 4? Does that make sense? Okay. But it turns out that if we had done that whole, which I'm not going to make you guys do, if we did that limit summation thing here, we would find that this adds to negative 4 because the areas beneath the x-axis are negative, the areas above the x-axis are positive, yeah? Okay. So if I want to know the net area between 0 and 5, I would just add those two things together. Okay, and I would get 5, because that is the net area. If I wanted to know the total area, I would do 9 plus the absolute value of that negative 4. I wouldn't care about the negative. And that would be 13. Are we comfortable with this? Not so bad. Okay. So for these last ones, when our functions make lovely graphs that are nice and easy and we can use, that are traditional areas, we can calculate that integral not by using calculate that area using like what we know about the graph. So what do you guys know about the graph 3 minus the absolute value of x?
It's a triangle, but it's down 3.
Well, absolute value graphs are typically V-shaped, but because that's a negative absolute value, it's going to flip down. And then that 3 is going to move it up 3. So like here's 3, and it's going to look like this. And it's actually going to hit, what values of x make the whole thing equal to 0? Negative 3 and positive 3. Yeah? So if I'm asking for the interval of between negative 3 and positive 3, right? That's my interval. And I'm saying, if I ask you for that integral, I'm essentially asking you for the area between. I'm essentially asking you for this area. How could I find that area? It's an area. It's a triangle, yeah? So it's, well, this distance would be 6, right? So, and then this distance would be 3, and so we would do 3 times 6 over 2, which is 9.
I like this one a lot better.
I told you that this second half wasn't going to be so bad today.
The second half is like 10 minutes long.
That's not true. It's going to take me more than 4 minutes to do these last two. That's not true. It's going to take me more than 4 minutes to do this one. It's going to take very little time to do this one. So maybe we'll see. Guys, what kind of equation is the square root of 64 minus x squared? What do you think that's going to look like? First of all, what is x allowed to equal? Where is this function defined?
From 8 to negative 8.
So like, here's what I know. In terms of figuring out where is it defined, 64 minus x squared has to be greater than 0, yeah? Which means 64 has to be bigger than x squared. For which values is that true? It has to be between 8 and negative 8. Because if I'm bigger than either of those, then that x squared becomes... Is everybody good? Okay, so here's 8, or here's negative 8, here's 8. And it turns out what this is a circle.
Oh, cute.
It's the top half of a circle. And if we think about a circle with radius 8 would be x squared plus y squared equals 64. That's how if it's centered at the origin. Think about getting that y by itself. Is this okay? All right, so if I'm finding the area between 0 and 8,
So it's a quarter of a circle.
it's a quarter of a circle. So I don't know, guys, I'm not very good with numbers, so can you guys help me out? What is the area of a circle? Pi r squared. That's the circumference of a circle. Okay, so if my area of a circle is pi r squared, and I have a fourth of this circle, I could do pi r squared divided by 4. Which would be, in this case, pi times 8 squared divided by 4. How we feeling? I don't know what that is, though. 16. 16 pi, which is, you know, approximately 50.27.
Wait, isn't that r squared radius and not diameter?
It is, but what the,
Diameter would be 16, wouldn't it?
yeah,
Um,
that is 8. Cool. How is this one different? Because it looks to me like super similar, doesn't it? This one's asking for both sides, yeah?
1/2 pi r squared.
So if we wanted to do 1/2 pi r squared. But guys, I don't need help with that one. I bet it's 32, and then I bet it's 100.53, because my bet that 50.27 was probably like a 50.263 or something, or 264.
You're a little silly.
Yeah. See, I told you it was going to take more than 10 minutes to do the second half.
Oh, boo.
Guys, so that was a great question. We did the wrong quarter of a circle, for sure.
The answer is that.
The answer didn't change whatsoever, obviously, but we did this area, yeah. For sure. So it definitely, see, now it's like bordering 11 minutes on the second half of class.
You're right.